Welcome to this webinar from GeoCap. Today we're going to take a closer look at seismic interpretation with the latest update to our ground model add-in for ArcGIS Pro. While we're focusing mainly on offshore wind projects today, keep in mind that you can use this functionality in any subsurface mapping project. If you have any questions during the session, feel free to use the chat and we'll do our best to answer them as we go along. So let's get started. As everyone is leaning towards more renewable energy, offshore wind farms are getting a lot of attention. But there's a catch. The success of these projects largely depends on how well we know what's below the sea. By mapping the ocean seafloor and subsurface, we get a good understanding of the geological conditions and potential hazards. This step is crucial for designing stable and safe foundations for wind turbines and making sure cables are protected. If we get these conditions wrong, we're facing a lot of risks, long delays, and large cost overruns. So to minimize these risks, we gather and analyze seismic data. This process is normally time-consuming and requires a lot of manual work and involves software that doesn't work well with other types of relevant data like bathymetry, side scan, magnetometry, and geotechnical data. This makes it tough to mix and match data and share insights across different disciplines and with various stakeholders. In this webinar, we're going to show you how we've beefed up ArcGIS to make sure this process goes a lot smoother. I've got Henrik with me here, and he's the product manager at GeoCap. He's going to share his insights and show you a live demo of these tools in action. But before we jump into that, let me give you a quick introduction on GeoCap and ArcGIS for those of you who might be new to us. ArcGIS is a geographic information system, or GIS for short. It lets you create, manage, analyze, and map all sorts of data in the context of location. It's developed by Esri, the global leader in location intelligence and mapping. Here at GeoCap, we're proud to be an Esri partner, and we've taken ArcGIS platform a step further by integrating subsurface capabilities. Our ground model add-in for ArcGIS Pro is perfect for managing, visualizing, and analyzing seismic data and geotechnical boreholes directly inside ArcGIS Pro. We also offer the subsurface portal for ArcGIS Enterprise, which is great for sharing, visualizing, and collaborating on subsurface data and interpretations in a web environment. Today's topic is the ground model add-in for ArcGIS Pro. And Henrik, could you tell us a little bit more about who the users of this add-in is?
Absolutely. Our clients, they range from survey companies, engineering firms, wind farm developers, and also governmental agencies. So there's a wide range of professionals benefiting from this software, including GIS experts, geologists, geophysicists, geotechnical engineers, project managers, and also other decision makers.
Great. And can you tell us a bit about the feedback we're getting from these users and what functionality they find valuable?
Sure. One of the great benefits is that the seamless integration with ArcGIS Pro, since many of our clients use ArcGIS Pro on a daily basis. So it makes a big difference to integrate as much data as possible into one single platform. So this integration allows them to quality check their data and gain a better understanding of the full picture of the site. And of course, they also appreciate our visualization capabilities.
And what are some common requests and suggestions that come from our users?
Well, one of the things that we have heard a lot is questions on the functionality in terms of seismic interpretation or interpretation in general and analytic capabilities. So many of our clients, they are eager to consolidate their workflows, to into one single platform to save both time and money, and of course costs related to software. So there's definitely a strong demand on expanding what our add-in is capable of doing.
All right, so can you show us some of the latest development on this front?
Sure. Yeah, let's dig into the details here. Okay, so what we are looking at here is a dataset of 197 seismic 2D lines. The green lines that you see in the map is interpretation that I have performed. To the base of the screen, you will see a seismic profile with some purple dots, and they are in fact interpretation that has been made on intersecting seismic profiles. There's a cursor tracking so that you can see in the map exactly where you are on the seismic profile. Picking what seismic you would like to display can either be done by selecting the seismic line in the ground model table of contents like this, or you can simply use the display button and pick seismic lines directly in the map. If you wish to edit the set scale, you can do that by using these arrows here, up and down. If you would like to see the seismic from the other direction, you can use this flip axis button on the toolbar.
What if you don't like the black and red color? Can you change the colors on the seismic?
Yes, you can do that either on survey level or on individual on profiles on seismic lines individually. If I find this seismic line here in the table of contents, I right click and go into settings, and here I can pick both which color scale I would like to use. For example, the the yellow, black and white, and I can also edit the range, the data range that is being displayed, either by a percentage cut on each side or each side individually like that. But for now I will stick with this red, white and black scale.
Okay, so your laptop screen is quite small. If you have an external monitor, can you move this out?
Yes, you can. So this ground model viewer here is possible to just undock from Pro and drag onto your second screen if you have duplicate screens. You can also then, of course, keep make your map window big so that you're working on both screens.
So when you interpret, how is the data stored and organized?
Well, the interpretation lines that you see here in the map is, if we open the interpreted horizon in the table of contents here, you see that each interpretation line is stored and organized as a feature in a feature class, with each feature representing the interpretation on one single seismic line. If you would like to project seismic interpretation from neighboring lines onto the profile that you are working on, it is possible to do so by using the buffer tool up here on the ground model toolbar. So ticking that off will display a buffer zone around the line you are looking at in the map. In this case, I will adjust the buffer distance up to 200. That means a buffer zone of 200 meters out on each side of the line. By doing so, the interpretation will be projected on like this on the profile. Performing interpretation is done by inserting an empty interpretation feature class and toggling it off and right-clicking and setting as the active interpretation horizon. When that has been done, you can see that the horizon is active by looking at the header of the seismic profile. When an interpretation horizon has been set active, the interpretation section on the toolbar will be activated. You can pick no auto tracking, meaning manual interpretation, and 4 different kinds of auto tracking. You can also pick the part of the seismic signal that you would like to track, either max amplitude, minimum amplitude, or zero crossing. So we can start off by a manual pick. So that will draw a straight line in between the points that you pick on your seismic, like this. If you're happy, you press OK and it will be stored. Now let's try the auto track internal. This will draw an auto track line between the points that you pick, and I'll stick with the max amplitude tracking. I'm happy, and then I would like to select another line. Let's do this one. And I will continue to map out where I see the crossing interpretation. You can see the map is updated as we move along, and when I double click or press OK, you will see the seismic in the map. Now I'll just switch to auto track right, and you will see that my auto tracking will shoot towards the right, and in some cases it needs to be corrected as you move along. Auto tracking left works the same way, and auto track left and right will do the same, but in both directions at the same time. If you would like to erase interpretation that you're not happy with, you can do that by using the delete button up here. So you press that and you draw a polygon around the parts that you would like to remove. And when you double click or press OK, that will remove the part of the interpretation that is within the polygon. Now, if you'd like to see your seismic interpretation in a 3D viewer, that is possible if you open a new 3D scene by hitting this button up here. The 3D window will open in the ground model viewer, and you locate your interpretation horizon in the ground model table of contents and toggle it off. You might need to hit the right click and pick zoom to. Quite a few of our clients receive ready-made grids, and these grids, they can be converted to seismic interpretation lines where the grids intersect with seismics. And that is done with the tool that we have in the ground model toolbox, which is called Create Seismic Interpretation from Raster. When that is done, you can edit your interpretation, and then regrid to correct the initial grid. Okay, if you would like to make a grid of your interpretation lines, that can be done by using these interpretation lines as input, both for the grid itself, but also for the boundary. So when using these green lines as input, I can get a grid that will look something like this. If I display that interpretation in my ground model viewer, it looks like this. I mentioned that it was possible to generate interpretation from a grid that was already imported into a ready-made grid that was imported into the project. So here I have made that kind of interpretation from a grid. So let me find the interpretation lines that I have generated from this ready-made grid. Here they are in purplish blue, and let me also find the resulting grid that I have generated from these lines. Here we go. I'll turn off the interpretation to make a better view in the map. And I would also like to see this grid in the ground model 3D window. So let me find that in the 3D scene in the ground model viewer. And there we go. I'll toggle on a seismic line also, just to get a nice view. In the ground model, you can work with seismic in both the time domain and the depth domain. So if you have performed your seismic interpretation on seismic in the time domain, you can actually domain convert that grid with the tool in the ground model toolbox called depth convert. In there you can actually convert grids in both domains, so that you get the depth domain from a time grid. But if you wish to go the other way around, that is also possible. In both cases, you can use whatever unit you would like.
Thanks, Henrik. So you spent 15 years in the oil and gas industry as a seismic interpreter. How does this solution stack up against the other solutions that you've used before?
Well, a lot of the seismic interpretation software out there is really they originate in the oil and gas industry, and they tend to be pretty heavy duty and make the job more difficult than it really needs to. In terms of shallow subsurface work. So our solution is really tailored for this kind of mapping, and it's integrated fully into ArcGIS. So you're not only getting just the basic map functionality, you're tapping into some of the most advanced GIS capabilities out there. You can directly import AGS files, which lets you correlate your geotechnical data with your seismic quite easily. So with all other data you already have in your ArcGIS, you get a much richer context while interpreting. So we're also adding features for picking targets these days. Like UXOs, boulders, cables, and this can really be a hassle in other systems. And of course, a very important note is that our software today supports the VDS, the seismic VDS format.
Yes, we haven't talked about the joys of seismic formats yet. And a lot of companies working in with subsurface data in offshore wind struggle with managing the sheer volume of data. It's a huge challenge, especially with seismic data, which needs a lot of storage space. It's costly to store all that data and difficult to share it with different stakeholders. That's where we think VDS can really make a difference. VDS is an open source format, which is quite new. It's a format for seismic data created by Blueware. It's vendor neutral and offers a variety of compression algorithms to help save on storage space, depending on your needs. Plus, it supports streaming directly from cloud storage like Amazon S3 or Azure Blob. This doesn't just cut down on storage cost, it also enables more collaborative workflows and enhance operational efficiency. In the ground model add-in, you'll find tools that let you scan SegWi files to inspect headers and preview navigation. These SegWi files are then converted into VDS files, which can be stored locally on a file server or in the cloud. We then generate a feature class that includes the navigation of the seismic with an attribute which points to the VDS file. This setup allows you to stream seismic data directly from the cloud to ArcGIS Pro, just like Henrik showed today. This opens up all kinds of possibilities for sharing data with stakeholders without having to move or duplicate massive amounts of data. This is a big leap forward in managing seismic data. And if you want to learn more about this, we will have a dedicated webinar on this topic soon. The best way to stay informed about upcoming webinars and other news is to sign up for our newsletter on our website and follow us on LinkedIn. So that's all for today. Please don't hesitate to get in touch if you have any questions.